In this video, we're going to look at some hard exam questions involving surds. So in my first example, we need to write this expression in the form k square root of a. So I need to manipulate this expression a little bit. I'm going to start by simplifying the first square root. Okay, so I'm going to simplify this square root. I can split square root of 300 into square root of 100 times square root of 3. I also know that square root of 4 is 2. Then with the second fraction, I need to rationalize the denominator. So that means I need to times the denominator by root 3 and times the numerator times 3. So I get rid of the surd from the denominator. That is going to be 10 root 3 over square root 9, which is 3. Okay, now in this first fraction, I can simplify and I can cancel. So I can cancel 1 and 4. I can divide both of them by 2. So that's going to be 1, that's going to be 2. So now in the first fraction, I have 2 times square root of 100 is 10, root 3 over this 3 here. That 3 is this 3 here. Then I add 10 root 3 over 3. 2 times 10 root 3 is 20 root 3 over 3, and I add 10 root 3 over 3. That is equal to 30 root 3 over 3, which simplifies to 10 root 3, because 30 divided by 3 is 10, so that's 10 root 3. In the next question, I've got some fractions involved and fractional powers. Okay, so I know that a power of a half is equivalent to square root. So this first fraction can be written as a square root of 4 over 3. And then the second fraction can be written as the square root. But because we have a fractional and negative power, I need to remember to use a reciprocal. So that means instead of 1 over 3, I'm going to use just 3. Now the first fraction, okay, I can write as square root of 4 over square root of 3. I know that square root of 4 is 2, and I still have square root of 3 in my denominator. I will have to rationalize this denominator. That means that I need to times the numerator and the denominator by the same number. So that's times root 3 times root 3, just to make sure I get rid of the surd. Now in my denominator, I'm going to have root 9, and I can square root 9, which gives me 3. So in my numerator, I have 2 root 3 over 3, and add root 3. Now I want to be able to add the two, the fraction and the square root of 3. So I'm going to write the square root of 3 as a fraction with the same denominator. So I can write square root of 3 over 3, because I need the same denominators, but then I have to times the numerator by 3 just to make sure I don't change the value, because if I now cancel 3 and 3, I'm still going to get square root of 3. So now that the denominators are the same, I can simply add So now I've got 2 root 3, and I can add 3 root 3, so that is 5 root 3 over 3. Remember, the denominator stays the same. In my final question, again, I've got some fractions involved and some mixed numbers as well. Okay, so first I'm going to convert the mixed number into an improper fraction. So 9 times 4 plus 12, this is 48 over 9, that's square root. We add a third to the power of a half. Remember, a power of a half is the same as a square root. So it's a square root of a third. Okay, now I know that this square root of 9 is 3, and I can split 48 into square root of 16 times square root of 3. Okay, now this fraction, square root of a third, can be written as 1, because square root of 1 is 1, and then square root of 3. Square root of 16 is 4, so that's 4 root 3 over 3. Now, in the second fraction, I need to get rid of the surd from the denominator, so I need to rationalize the denominator. So I need to times both the denominator and the numerator by square root 3. So that's going to give me root 3 over root 9, which is 3. And now that I have the same denominators, I can add the two fractions. So 4 root 3 add root 3 is 5 root 3 over